Hello guys, here is another video, and the last video we talked about meshed lists, so I thought it's only proper we do, which was easy. I think that was question 21. So just two questions below we have mesh key sorted list, right? It's same question, just that this time around we have an array of lists that's passed, not two. So the question reads, you are given an array of k linked lists. Each linked list is sorted in ascending order, right? Merge all linked lists into one sorted linked list and return it. And then you have an example input, then you have the array of sorted list, and then the output of a single sorted list, explanation, the linked lists are that merging them into one sorted linked list. And then we have a constraint that k is equals to the list.length, right? Right, the length of the list. K is between 0, including, and 10 to the 4th, including, which means that we can have that many amount of up to 10 to the 4th linked list, and every list each value, every list, the length of every list, that's the number of nodes. We can have 500 different nodes for each list, and yeah, it gets just really complicated. Yeah. And every value within any particular list can be between this number. So this says that you can have 500 nodes within any particular list. Any value can be between the number of within any list, between this negative 10 to the 4th to 10 to the 4th, and then the list. So every list is sorted in ascending order. Sum of list I. So the sum of the length will not exceed that. So yeah, those are our constraints. How are we going to fix this problem? Because, well, we just saw the other one, so that's the last video, and in essence, and we use the dummy idea, and then we basically we compare each node starting from the first for all the list, and then we implement just the smallest node, and then we do that for all the nodes. It's same, I think it's the same method we're going to follow here, but how do we do that? So so first of all, we'll just like initialize our dummy here, which is basically the same thing. This node dummy equals to new list node, and it's just going to have like 0. It can be negative or it can be anything, but the point is we're not using that. And then of course we're returning dummy dot next, which is our head. So this is what similar. This is how we did for the last video. And then of course we have tail, which is another list node. Tail, which in this case is going to be dummy for the time being. And then now comes the problem where we traverse the array of lists. So we have an array that contains list nodes. You can get the length of that array. We can traverse that array to get each list node. It's going to point to the head. Each list node, so we're going to have list that I point to the head. So let me just so we're going to have list I is going to point to the head of the list at I, and we're going to have list of I dot. So basically you get the idea. So we're going to have dot next. You can have list of I dot value to get the information for that particular list. So I'm just outlining this for it to be clear to me. Traverse the array of list. So list of I. So let me see. We're going to have 4 int I equal to 0, I less than list dot length of I plus plus. Yeah. So okay, what's next? What do we do? So at this stage, we have I plus j. So this allows us to get these, and these point to. Not exactly sure why we have the I plus j here. Yes, linked list. So this for loop allows us to get these. Okay, let me see. Booleans here. I'm going to explain what I want to do. Boolean equals to false. Let's say true. Yeah. And we just have a while true. Sorry. Boolean is end. Is 4 ends. Now I need to make sure I once saw something like this. where we have a boolean, right? It's a boolean, it's a list of booleans, and ends equals to yeah, cap ends, so we can have new boolean. Can we do that? Can I, let me see. Yeah. Let me just, I want to try something. So I have boolean. So boolean 5. Okay. Okay, so I see what I have to do here. Yeah, that skipped my mind. Is it wrong? New boolean, and it's going to be the length of list that length. I hope that works. Um, so we have while true. I don't know if it's, does it then implies true? So then implies true. Okay, it doesn't necessarily. That would be, so I have to manually, yeah, manually do the true thing. We can have the first for loop, yeah, I think, which could be, but I don't think, I have like default values. by default they're false. Okay. Is there a way we can make them all true by default? Is there a way? Yeah, you should like define it somewhere. You should be able to like define the values somewhere and then anyway, so that by default they're false. Okay. So we have that by default we have a false value. And we want to because if we do it, if we try to make them all true, then that just adds one complexity there. But can we work with a false value? Makes them like they're all false. We don't reverse psychology, it's just checks. By default, they are all false. I want the y true. We go want to do for I equals to okay. This is tricky. We extract all the the for loop extracts all the lists, but we cannot save it somewhere because that you need to define the variables before time. So it extracts all the lists. So this extracts all the lists, so it allows us to get something like list I and be able to do a check. How to find the smallest value. want to do list node minimum will equal to, I don't know if I should have like a new list node, a new one. So this should be out here. Right, minimum. Right. Mm, hmm. That's interesting. So if I is less than, I want to do I plus 1 here. If I is less than list of length minus 2, that allows us to do I plus 1. Like 2 while loops. Let me see. Yeah, pardon me. Like, we put this one inside here. I got this one. So we'll take this, simply just increment that. We'll find a minimum. Because I want to do, so basically do like int I equals to 0, right? And then we want to do while I is less than 1 minus 2. Yeah. I want to do this instead, and then we'll do I plus plus. This eliminates the for loop. At the same time, allows us to go through the for loop and do this check here, which is what I'm going for, so that I can go list, so I can do if list of I value is greater than list of I plus 1 dot value, because that's the head, by the way. Let's do less than equal to first. I think it's clearer that way. And then just do minimum here. Just do minimum equal to this value. So do a ternary operator. And then if this is less than, then we want to simply just assign minimum to list the value. Let me see. Yeah, I'll just have list.I. That's what we'll assign minimum here. Else we want to do I plus 1. So this will compute it right up to the last bit 1, so that you have the extra 1 to be able to do this computation. So this will loop right up to the last bit 1, so I have the extra 1 to be able to do the computation. And then we're going to have the I plus plus, and we're going to find minimum. So this basically finds minimum for every array. And also I want to save the index. I want to save int index. So just like minimum index, min index will be equal to, for now it's just going to be 0. Or we could just, since we're assigning it anyway, we could just put minimum index will be min index equal to I. No. Min index will be the same thing, but we'll do the I plus 1 and I plus 2. Min index will be I here, do I here, and they will do I plus 1. Yeah. So that will be the minimum index. Now we are supposed to compute against the minimum, against the minimum. Yeah. Okay. All right. So minimum is equal to minimum will be equal to 0 here. I know it's a bit rough. And then I equals 1, since we already take the first index and we're assigning to minimum. And rather we're going to do is minimum greater than I. So it's basically, and then the index is going to be 0. 0. And so this is better, this is way better. And then we're going to have minimum equals to is less than equal to minimum, right? Min dot value. If that's the case, then we want to do that is dot I, else we want to just maintain min, right? Min equals to min, which basically doesn't do anything. Same thing here. So basically same check. And then it's just going to be minimum index. Right, we just maintain that. So we don't change anything. So if so the point so we initialize the first node, right? So the minimum to the first list, right? And then the index, which is at 0, so we initialize it, and then we start at 1, and we just want to end right, so we don't care about the -2 anymore. We just want to end at this is less than that. I is less than the length, and then we want to check if min is equal to, I mean, if the minimum value, the current minimum value, is greater than the list, the head of the list index. So yeah, because this basically takes just the head. Remember, these are all linked lists, so it takes the head here, it takes the head here, it takes the head here. So we'll call the value, we basically get the values of this list, and so we want to check if the next list, the value of the next list, which is this, is less than the minimum, the value of the minimum, which we initialize here, which at this point is this one, right? And when it gets here, we're going to check this one against whatever minimum is there. And that's what we want to do. And we want to save that index because when we find the minimum, right? So we have the minimum, we have the minimum list node, the minimum node from all the lists, and we have the index. We want to increment the list for that index. So we want to point the head of that index of the minimum to now become the next of that head. So essentially, the first thing we'll do is, so we have our dummy here, remember, right? We want to assign it to, so we have our dummy and our tail. So when we have gotten the minimum for that, we simply want to now take our tail. So we want to do assign min to the tail, right? And basically it will be tail dot next, which is equal to new list node, right, of min dot value, right? And we want to increment, right, the list. So we want to do lists of min index, right, dot next. So we want to do min dot equal to this dot next, right? So yeah, this does not, so this is useless now. What we want to do, so we are able to compute the minimum value for every one of them. It's going to do that, and it's going to do while true. But we need a way to break out of this. And remember, we need to make sure that when we are breaking out of these, either we have exhausted all of the nodes for each linked list, right? Or we are left with one linked list which still have remaining nodes, right? Just one, which means that the remainder of them should have been exhausted. So that's the option that we are left, and we need to find a way, which is, I think, it's why I wanted to do something like this, so that, I don't know. How do you feel like we're going to break out of something? Because in the other section we do the while something, list node is not equal to list node. However, the list nodes are difficult to get. Oh, and also there's a problem here, because we are going to have values so we are going to do while I is less than length, right? And list of I is not equal to null, right? Yeah, list I is not equal to null. This makes the issue of running this computation on a null value. So it saves that. However, I need to be able to break out of this. So this, I just used it for the fact that I took placeholder. So I need to define something proper here. So what do I need to define to keep it within the constraints? Because I think this works well, but now this loop up there is the problem, where I don't know what, because I think, because what will happen is it's going to come, we're going to go here and then come and loop through. It's going to select each list and it's going to check, as I is still less than the length of the list, so while I is still less than the length of the list, and the list at current I is not equal to null, then we'll be able to do this computation, right? Because as you can see, so why this is not equal to null is going to run this computation, which is going to find the then okay, this is really hard for me. I just use like a counter or something that allows me count the number of times I have exhausted the list. Because when I do it at least the next, I can check down here to make sure that list.next is not equal to null. You can just run if list, well, let's just say is equal to null. Then I may want to update a counter. Instead of this boolean here, if we have a counter here, will it work? Let's say int null counter. At this point equals to 0. Assume that it's none of them are null, right? minus minus, maybe minus minus, and then here we can have counter should be the length. Yeah, this dot length, something like this. And then here we want to break this when and only when the counter becomes, say, equal to 1 or 0. So we want to loop as long as counter is greater than 0. So if this is the case, then let's say we take an empty list. An empty list is going to come and it is going to, the counter is equal to 0, yeah. So counter is greater than 0 is equal to 0, so it's just going to return this. So this will pass. And the counter here will be 1. Counter here will be 1. So counter is greater than, it's going to come and it's going to say list is equal to 0. I'm going to take the first list and assign the minimum to that list. And we're going to assign the minimum index to 0, which is correct. But it's going to check here I is less than this. I is less than, which is 1. But it's not less than length. I is equal to length here. So it's going to skip this. Yeah, as it should. It's going to skip this and it's going to come down here and say tail.next is equal to new list.minimum.var. But min list is an empty, right? It's literally like a null value. And so min.var does not, so this var is not going to work here because not equal to null. Then we want to do that. Access null. No. Still just no, I think it's supposed to be here. Min.var, because the issue will come out from here when I'm trying to assign min.var, because it's null. You cannot have a value of null, so there is nothing assigned there. So we also have like an if function here, I think. Check if min is not equal to null, right? Then we're going to have all of that thing inside there. should be, I think this should be outside. Yeah. So but if it's equals to no, then we should not do anything. We should just leave it, right? Because then we've got it, I think, to the end of it all, and then the counter is going to decrement. So this should pass to with this because it's going to come down here as is min.val equal to null. Is equal to null, so it's going to skip it and it's going to decrement. So it's going to ask, so what's the list here? List.min index, which is 0, which is this one. If it's equal to null, it's going to decrement this counter, and this counter now becomes 0. Remember, it was 1 up there, and it's going to skip and simply just return dummy.next. And remember, I've not done anything to dummy.next, and dummy.next is just an empty string, so it's going to return 0. So this one and this one passes, but does this first one pass, right? Let's run it and see. No counter, sorry. Oh. Yeah. Okay. So I think we're done with these edge cases, if I'm not mistaken. But this case itself is not done, so I think we're making a mistake somewhere with the calculation. And so it's going to take the first one and it's going to check which one is minimum. So it's going to come here and assign 1, come here and assign 0, and then it's I less than that. Yeah, that's true. That's 1. It's not at 1, so it will come here. It's less than 2. I mean, it's less than 1, 2, 3. It's less than 3. So 1 is less than 3, and it's list.I not equal to null. Yeah, it's not equal to null. So we're going to have minimum is equals to list I dot value. Is list I dot value less than or equal to? List I dot value, which is this one, is it less than or equal to minimum dot value? Yeah. And so we're going to assign to this, we're going to have minimum. We're going to assign minimum to this one, and then we're going to assign a new index to I, which is going to be 1, 1. And then we're going to increment plus plus, and we're going to check again for the second, for this one, and it's no, and we're simply just going to maintain the same stuff. And then we're going to come here and see if min is not equal to null, which is true, then we're going to have tail.next equals to new min.value. Oh, okay, yeah. I forgot to tail is equals to tail dot next. Yeah, that should at least produce different results. 5, 6. Okay, all right, that's what I'm talking about. So you see, I think one of them is longer. 1, 2, 3, 1, 2, 3, 1, 2. Okay, that doesn't make sense. Well, it works. It really works. It works, but I am shortening something. I think I'm shortening. I'm going to short somewhere. And I'm not noticing. Yeah. I'm doing a short somewhere. I'm not noticing it. The I less than or equal to 1. No, that's not a problem. So we increment here. So we compare. We get this one, right? And then we increment with the minimum index. Yeah, no, that's okay. That's okay. We'll get the first one, right? And then we try again. And then now the second one we compare this, and but we'll be comparing with this and this, which would then still choose this one, and then put the index to 1. And then we'll try again. We'll get this plus this, which then choose 2, and it should increment 2. And then we'll try again, which will then choose this plus this plus this, which will then choose 3, right? And then we'll put the 3, and then we'll try again. Well, increment here, which will then choose this compared to this, which will then choose 4. And then we'll have this compared to this, but when in order to compare, rather I think we should just put this in an if, right? We should put this in an if. Yeah, I think it should be in an if here. If something like that. Then we have something this sort. We have all that. and then this comes out from here. In other words, we're asking iterate all through the list. Why? So it's going to compare each. Basically, if list.I is then it's going to compare that. What the fifth time? Yeah, now we're going to increment plus here. No, that should do it. What's happening? It's supposed to work because we're getting the I and we're checking if it's less than less. So it basically iterates and gives us access to this. So we're saying that whenever we are checking this, so minimum dot value, it's not exactly minimum value. So the lists I. And if list I is not equal to null, then this value is not supposed to, I'm not supposed to be getting an error here. I mean, basically I'm checking it here. So if I'm getting the error from this value, it doesn't make sense. That doesn't make sense. Okay, let's reverse. Okay, we had this. We had this, which, well, kind of went through the entire thing, just that did not pick up the last value. Is cutting out the 6, which I'm thinking we're cutting out, we're ending something too early. We're ending something too early. minimum is that, and it's going to check if minimum is okay. 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 Huh. Yeah, okay, so I see the problem. I see the problem. Since we're checking minimum, I think it's checking, and when it gets to 5, minimum is still 5, and when it gets to this check, no, minimum is still 5. Okay, minimum is still 5, but then it should add like 2 5s here. So it's actually one node short, one element short, which kind of make the things not good. We have this, it's going to select this and compare this into this, select, and this is going to select this one, then compares this to this to this, select this one, compares this to this to this, selects this one, compares this to this to this, selects this one, compares this to this to this, which selects this one, then compares this to nothing to this, selects this one, compares nothing to nothing to this. We're supposed to select this one, right? Ooh. No, I'm not computing this well. Most definitely I'm not computing this well because I'm initializing a node to 0, which is this node. I'm supposed to do each time it comes, it's going to initialize to 0. Yeah, it doesn't really matter because yeah, we're incrementing that. So this is correct. We are incrementing the year, so it doesn't matter. Yeah, it doesn't matter. So when it comes, okay, when this one becomes null, oh, okay, I see. So when it comes null, this becomes null. So this so at the end, you realize that what happens here, I think I've seen it, is that we'll get to a point where these two are null and this is the only one to compute. Okay, you get, so these two are null and this is the only one to compute. We'll get to that point, which is where we want to get to, right? Then it breaks the chain when this is false. When it breaks that, it comes here. So okay, this is tiring. Breaks the chain. I feel like there's a problem in this check here. Yeah, there's a problem with the check there. Although this passes well for most part, I feel like there's a problem with the check there. Which is why I wanted to remove this check to the secondary part, but then I'm getting the null pointer exception. Okay. Because this one will get to, one of the things I'm wondering is that this breaks, right? So if we get to a point where this is null and we have to add just this one plus say this one, okay, so we have to add, so this is already null, we have to add this one plus this, so we'll have, you initialize to 4, right? There's a section will get initialized to 4, and then this is still 0, and then it's going to ask, is I, which is 1 now, less than the length, which is true, and is least not equal to null. So it's going to say true, and then it's going to compute that true, right? So it's I, which is 1, and this is the next one, and this is going to be false, right? Once this is false, I think it breaks this loop here. Or am I wrong? So it breaks this loop, hence we're able to get our second 4. However, if things were a bit different, we will not be able to get this 4 here. You understand? So this, in my opinion, I feel like this should not be here, right? This should move down inside here in an if function that checks if the current list I is not null. That way, it does not break this loop, but just skips this. It doesn't break this loop, but skips this I calling it this block of code when executed, right? And still increments. And that's the idea I had. However, when I run now, in my opinion, this should work, because when it gets to a point, it's going to ask. So when it gets here, it simply just asks that, are we up to a point where the index is less than? So we're basically just traversing the array, right? That's all we're doing here. And then we now execute this block of code depending if there is some value here to be computed that can execute this block of code. if there is no value, we want to skip it. That's the idea. Because there is also the idea here that we get to a point where we have a null value here. Okay, we have a null here, and so the minimum is set to 0, and we have a null here. So when we try to get the minimum dot value, which I think is the problem we get when we run this code, is that when we try to get the minimum dot value when we have already executed this and it's left just this 6, this is going to ask, because you see this asks the question. So we'll get to this point where we have this, so I2, right? And so it's going to be pointing to 6. So when it asks this question, this is going to be true. However, when we see we're getting minimum dot value, at that point, minimum is equal to 0, is equal to null, and so we cannot get the dot value of it. And that's the problem. You understand? So what I want to do, and that problem, the problem of the minimum value comes from here, like this, which is interesting. And I'm trying to use this minimum to be able to compute. So it's a bit, yeah. However, so I think this logic here is the main problem, because we have a point, so this is kind of correct, but we have a null pointer exception in the cases where, this finishes before the other computations are finished. This number, this becomes null, and this becomes null before the others become null, where we have minimum is assigned immediately to 0 to the first list, which then is null, so we cannot have minimum dot value null. But so I don't know if we can move it to the while loop, where we can now get to ask within the while loop and compute minimum, because the idea is to compute the minimum between all the arrays. And I don't know, probably I might go back to this first solution so that we should be able to move this in here, so that rather we should just have minimum, right, without the initialization, and also have index without the initialization, and then we do the initialization here, where we have minimum is going to be the dot value, and then it's going to be list I plus 1 dot value. But then we're going to have that and that. And what if there is no I plus 1? Oh, okay, so we're going to have I plus 1. I plus 1 is always going to exist. If it gets here, because of this check here, -2, and we're also using the arrays. However, if we have I plus 1, then we're going to check. So if list I equals list I is not equal to null, yeah, but that's the thing. That is the thing. Now, I want to have a minimum, but I need to be able to initialize it. I think this approach is better, but I need to be able to initialize it with something that does not interfere with the values. 10th, negative 10 to the 4th. What will I initialize it with? Because these numbers can be negative too. We can compute. Oh, okay, so basically, I can still do something like this, right? And I can do something like this, but here I can have something like and I is greater than 0. Here I can have something like that, and so I becomes 0 here. Yeah. So if I is not greater, else if we have the same thing but I is equal to 0, right? Then we simply just want to assign minimum to, you know, the initial index here. We simply just want to assign minimum to list of I. Yeah, and then this to I. That way we don't get the conflict. Let's say that internet connection. That's a classic one. Do we have to put this up here? Yes, if do we have to put this up? It's supposed to be like the same thing, right? So I is supposed to null. So if this I is not equal to null, I equals same problem, I think. Yeah. Say, I think what's the problem? Minimum index might not have been initialized. It's just too many nested ifs. I'm not happy with the solution. It's just too many nested ifs. Do you even we just give up? That that complicates matters. Okay, definitely complicates things. I know that the logic is just so close. Minimum index equal to null. Yeah, so this handles a case of first. It just when it's not equal to null. But what if it's equal to null? The minimum becomes null. They will have still have the error here. Cannot assign minimum is null. Cannot assign null value, which is okay. This avoids the cases of where the current list is null and simply just moves to the next. But then we have a problem of minimum not being assigned. When it gets here and asks when it finds where the list is not equal to null, right? And I is greater than 0, So we have an infinite loop somewhere. That's weird. This is not supposed to. I thought I took care of this already. Yeah, it's going to have minimum null, counter, minimum null. So I is equal to 0 is I less than length, which is 1, true. If list the idea here is if list, so it's 1 here 1, if list I, which is an empty null, it's not equal to null, well, it's equal to null, so that fails, equal to null, that fails, we do plus plus, then I becomes 1, and that escapes if minimum is not equal to null. Well, minimum is equal to null because it's still null there. Ooh, yeah. Yep, that becomes. I don't know if I can do 0. The point is that 0. Yeah, 0 will not go. I thought doing -1 will help. 0 will introduce bias. I'm not still sure about this solution. Oh, interesting. Does pass. Well, that's an interesting approach. I did not expect it to pass. With a 0 there. Okay. But yeah, we're terrible. Time complexity just completely horrible. And that's mostly because of the multiple. I think the checks, mostly just the checks. And the wires. And the while loops, 2 of them. Mostly just the checks and the while loops. Anyway, that's our own solution, which is just the worst of them. So finally we have a solution, and it's really bad on both the memory and the runtime, but it's a solution, and that's the good thing about it, is that it's a solution, and from here we can understand what we did and then try to make it better. Okay. I think, is there a possibility for us to remove one of these while loops, right? Because what I'm doing here is basically, I just have a map. I'm simply just going through I'm just looping until I go through each of the arrays and compare, right? Take this one, take this one, take this one, and compare each, and then put the greatest back in the first. Then take this one and the next that is here and the next that is here and compare. So in essence, just make it like I'm using the idea from how we solve this one, the last video. If you have not seen it, check it out. The last video, how we solve this one, LeetCode question 21. I'm using that idea. So I was doing documentation for it, and yeah, so I put it on YouTube, and this is the documentation for it. So the LeetCode idea tool. Look, check it out. The idea behind it, I think, do I have the solution here? Yeah. So if you look at the idea behind it, it's basically just making it one, just traversing through the list and comparing the values individually and incrementing depending on which value is lesser and from which list. So basically I use the same idea here. Yeah, it's a solution, it's just terrible, right? So we can now look at the better solution. And if you look at, say, the best under here, usually it will just be something that if you ask ChatGPT will give you. Class static one time get one time. This is Java. One time dot add short down hook new thread. This multi-thread. And we use queues, comparator. Anyway, in our own way, we are not going to do this. I'm simply just going to give GPT our code and ask it to give us a better version. So I'm going to say, hey, but solve the advanced version of the merge linked list. It is a solution, is an acceptable solution but the time complexity is horrible. Space complexities horrible. Can you do the following? So the first thing I want to ask GPT is, say, help improve a solution while keeping an idea of approach, right? And then second, another solution, this time the best approach regardless of our own approach. So explanation very necessary. So yeah, you see, even GPT realized that I try to keep it close to its list measure as well. Your approach works perfectly fine for small inputs, but as you already noticed, the time and complete explode when merging many lists, especially when k enter the number of keys and large. So there we go. Your current approach, keep a pointer for each of the key linked lists, blah blah blah. Immediately find the smallest current node among the list, append the smallest value to the result list, move forward in the list pointer, continue until the list is exhausted. Complexity, yeah, so it's just terrible. Yeah, it is horrible. Improve, keep your idea fixed efficiency. We'll still find the smallest node each time, but we'll use a min heap priority queue instead of scanning all the key lists. This is the updated approach. So if list is equal to null and list.length is equal to 0, return null, that solves that value. So min heap, that stores nodes by their value. Priority queue, yeah, this is something I've never used before. Yeah, I guess I'm learning something now. List node min heap to the minimum heap equals to new priority queue, and then we have a lambda function a comma b, a dot value minus b dot value. Add the head of each list into the heap. For list node, of list, if node is not equal to null, min heap dot add node, extract min. Anyway, so you get the idea. I'm not going to be explaining these things because I'll have to take time to understand them myself, and we've already exhausted a lot of time. So just look at it, pause the video, understand what you can, look at what GPT is talking. I'm also going to go through it when I'm done with the video to try to understand, and then we'll have the better optimized version, divide and conquer, which I think was the better approach. Mesh range, I thought I had this in mind at some point. Match k lists, yeah, explanation. Okay, thank you for watching. Like, subscribe and share. Yeah, see you next time.